In this lecture, we shall prove the most important theorem in this section. So let's begin with the definition. The space Z is said to be locally path connected if for every point Z in Z and any open set U containing Z, there is a path connected neighborhood V such that Z belongs to V and V is contained in U. So the theorem we want to prove is that f from x to y be a covering let G from Z to Y be a continuous map where Z is connected and locally path connected. Let Z naught in Z be a point and we denote Y naught to be G of Z naught and fix X naught in the fiber over Y naught. Then there is a lift G tilde such that G tilde Z naught is equal to X naught if and only if G lower star of pi 1 Z Z naught is contained in the image of F lower star pi 1 X X naught. So notice that both these are contained in pi 1 Y Y naught. If such a lift exists, then it is unique. So proof. If there is such a lift, then we have G is equal to F composed G tilde. And so G lower star pi 1 Z Z naught is equal to F lower star of G tilde lower star pi 1 Z Z naught. But that is contained inside F lower star pi 1 X X naught. So thus, one side of the theorem is obvious. So the main content is to show that if G lower star pi 1 ZZ naught is contained in F lower star pi 1 XX naught, then there is a lift G tilde. So let us first show that if a lift exists, then it is unique. Suppose we have two lifts. G1 tilde and G2 tilde. Let Z in Z be a point. Since Z is connected and locally path connected, this implies that Z is path connected. So let gamma be a path such that gamma 0 is Z naught. So it starts at Z naught and ends at Z. Then G compose gamma is a path from 0 1 to Y such that G compose gamma of 0 is Y naught. So by the unique path lifting theorem, there is a unique path G compose gamma tilde which lifts G compose gamma and starting at x1. On the other hand, G1 tilde compose gamma and G2 tilde compose gamma are paths which lift G compose gamma and start at x0. Thus they are equal. Thus G1 tilde compose gamma of 1 is equal to G2 tilde compose gamma of 1. So this implies G1 tilde of Z is equal to G2 tilde of Z. So this proves uniqueness. The above also shows how to define G tilde. So choose any path, gamma from 0, 1 to Z. Look at the path gamma from 0, 1 to Z. Sorry. Choose any path gamma from 0, 1 to Z. Then we get G compose gamma. Lift this to G compose gamma tilde from 0, 1 to X, starting at X0, and define G tilde of Z to be G compose gamma tilde of 1. So of course we need to show that this definition is independent of the choice of gamma. So assume we have two paths. From Z0 to Z1, from Z0 to Z. So here's my Z0. So we have one path gamma 1 and another path gamma 2. Then gamma 1 star I gamma 2 is a loop at Z0. Thus, G lower star gamma 1 star gamma 2 I gamma 2 is equal to G compose gamma 1 star G compose I of gamma 2 is equal to G compose gamma 1 star I of G compose gamma 2 is a loop at Y0 in Y. By our assumption, there is a loop H in pi 1 at X0 such that F lower star H, which is equal to F compose H. So F compose H is homotopic to this loop G lower star gamma 1 star I gamma 2. So the picture looks like this. So we have our X over here, and here we have a path H is at X0. and this is y naught is f compose h, and this is g compose gamma 1, g compose gamma 2. This point is g of z, and we have a homotopy like this. So thus there is a homotopy f from f compose h to g to a star gamma 1 star I gamma 2. There is a unique lift of this homotopy by the homotopy lifting theorem f tilde such that f tilde of 0 0 is equal to x naught. Since f tilde of 0 cross I is contained in f inverse y naught, and f tilde of 1 cross I is also contained in f inverse of y naught. So this forces that f tilde of 0 cross I is constant, and so it has to be x naught. And similarly, f tilde of 1 cross I is also a constant, so let's call it x1. And x1 is such that f of x1 is equal to y naught. But on the other hand, we know that f tilde, when we restrict it to this horizontal line, we know that the lift is exactly h. So f tilde restricted to I cross 1 is exactly h by unique path lifting. Since both of them lift f compose h, and both of them start at x naught, and since h is exactly h, since h ends at x naught, this implies that x1 is also equal to x naught. So this shows that the unique lift of g compose gamma 1 star I of g compose gamma 2 is a loop at x naught. So this lift is precisely given by this x naught is f tilde of t, sorry, half comma 0. This lift is exactly given by t goes to f tilde of t comma 0, and so the unique lift. Okay, so not unique lift. From this we deduce the following. The path t goes to f tilde t by 2 comma 0 is the unique lift of g compose gamma 1 starting at x 0. It ends at x. So this point we are calling x, and 2, the path t goes to f tilde of half plus t by 2 comma 0 is the unique lift of I of g compose gamma 2 starting at x. We just saw that this path ends at x 0. Now consider the following general assertion. Suppose we have a path in the base delta from points A to B. This is my y, and we have a covering map. And then delta is lifted from A tilde to B tilde. Let's call the lift delta delta. Then the lift of I of delta starting at B tilde is exactly I of delta tilde. And this ends at A tilde. So we apply this to delta equal to I of g compose gamma 2. So we get that the unique lift of I of delta, which is g compose gamma 2, starting at x 0 ends at x. Uh, but this lift is exactly, by definition, G compose gamma 2 tilde. So thus we have proved that G compose gamma 1 tilde and G compose gamma 2 tilde both end at x. So this implies that G tilde is well defined. Next we will show that G tilde is continuous. So we will use the following. Let H from A to B be a set map between two topological spaces. Suppose for all A, we can find open sets U containing A and V containing H of A, such that H of U is contained in V and H from U to V is continuous. Then H is continuous. So let Y be equal to G of Z and X be equal to G tilde of Z as before. Let V be an evenly covered neighborhood of Y. Then F inverse V breaks into a disjoint union of some UIs. Let W contained in G inverse V be a path connected neighborhood of Z. If S from V to UI denotes the inverse of the restriction of F from UI to V, which is a homeomorphism, then S compose G from W to UI is clearly continuous. And a lift of G on W. So let us show that G tilde agrees with S compose G on W. So the picture is as follows. We have Z naught here. We have taken some path to Z. We have a path connected neighborhood of ZW. Under G, this maps to V. The inverse image of V breaks into disjoint union of UIs. One of these UIs contains X. This is X. This is Y. So by definition, G tilde of W okay, so let W be in W, so this is the W. So we can take a W here and we can fix a gamma, and let's take a path gamma 1, since W is path connected, is by definition G compose gamma star gamma 1 tilde of 1. This is equal to G compose gamma so let's this is equal to G compose gamma star G compose gamma 1. We lift the whole thing and take the endpoint. But now this is equal to, so first we lift G compose gamma tilde, then at the endpoint of that path, we lift G compose gamma 1 tilde and then take the endpoint of this. So since G compose gamma tilde ends at X, as I mean that's almost by definition, as G tilde of Z is equal to X. We need to consider the unique lift of G compose gamma 1 starting at X and take its endpoint. But this lift is clearly S compose G compose gamma 1. And the endpoint of the lift is S compose G of W. Thus we get G tilde of W is equal to S compose G of W. This implies that G tilde the image of G tilde lands inside UI and G tilde from W to UI is continuous. Thus G tilde is continuous. This proves the theorem. So this is a very useful theorem, and let's see some applications. So first let's look at branch of the logarithm. So let I from omega to c star denote an open set. We want to know when there is a map log which makes the following diagram commute. So omega is contained in C star. We have the exponential map, and we want to know when there is a map log like this which makes this diagram commute. So let z0 be a point in omega and z0 tilde in C be a point lying over z0 in C star. Since C can be contracted, since C deformation retracts onto z0 tilde, so let's give this map, yeah, I. We have the fundamental group of C z0 tilde is trivial. Thus, applying our theorem, the lifting theorem, log exists if and only if I lower star pi 1 omega z0 is the trivial group. In particular, if pi 1 omega z0 is trivial, then such a log exists. However, note that the triviality is not a necessary condition. For example, we could take C star 1 and we could take an annulus of this type. So this is 1, and omega is this open annulus. So then pi 1 omega 1 is isomorphic to z because the annulus deformation retracts onto a circle, but I lower star pi 1 omega is the trivial group. So one way to see this is that we have inclusions omega is contained in real part of z strictly greater than 0. This is contained in C cross. So at the level of fundamental groups, we have let's call this U temporarily. And this group is 0. Okay, so this is one application. So as a second application, let's see the Potsu-Coulomb theorem. Let f from S2 to R2 be a continuous map. Then there is a point x such that f of x is equal to f of minus x. So proof: if there is no such point, x, then consider the continuous map G from S2 to S1 defined by f of x minus f of minus x divided by absolute value of f of x minus norm of f of x minus f of minus x. So notice that G satisfies G of minus x is equal to minus G of x. So we have S2 to S1 are this is the exponential map. And we haven't yet computed the fundamental group of S2, but let's just assume for the time being. So since pi 1 S2 comma P is trivial, there is a map G tilde which makes the diagram commute. So since g of x is equal to minus, well, since g of minus x is equal to minus g of x, it follows that g tilde of x minus g tilde of minus x belongs to the set z by 2 minus integers. And this is a discrete set, discrete, since S2 is connected. This implies g tilde of x minus g tilde of minus x is equal to q by 2, where q is an odd integer. But this happens for minus x as well. Let x equal to minus x. So then we get g tilde of minus x minus g tilde of x is equal to q by 2. So adding these, we get q equal to 0, which is a contradiction. So we will end here, and we have used this. So we will see this in the next lecture.